In the previous episode, we assembled the components of the electric car, suspended the rear axle, and did a test run. The plan for this episode is to set up the cooling system to properly test the car in real-world conditions.
Another batch of parts has recently arrived. I went and picked up the automatic transmission oil cooler, the main radiator, and the pipes, hoses for connections, clamps, and the auxiliary pump. Now I'm gonna clean all of this, test fit it on the car, and install it. The radiator is from a Nissan Leaf. The oil cooler is from Daewoo. I think I don't even remember exactly. I just chose one that had connectors on both sides and a narrow shape. The hose is an oil, gas-resistant type, and the pump is the right diameter. A Nissan Leaf one was much more expensive, so we got one from a Nissan X-Trail, clamps, and there are also these various fittings for connecting the oil cooler. I started test fitting the radiator in advance. There was no better place for it than over there. It'll change its angle of attack a bit, sit a little higher, and be at an angle. Here I've already started making a small mounting bracket for it. Right now I'm thinking about how to mount it properly without making it look makeshift. And I also have to plan ahead to leave space for the hoses so they don't get kinked. We won't have a fan for now. I don't think we'll ever actually heat up the engine enough to need to turn on the fan.
Well, the rest is simple, just need to install everything, connect it and test it. That's exactly what Kolya started working on.
Like this. Like this, without any kinks. It goes right here. We'll secure it right here. It should come right here. So we'll cut it here with some extra length, just in case.
For cooling the automatic transmission, we decided to temporarily install this radiator. We understood that most likely we would eventually replace the transmission with a similar one, but a manual which doesn't require cooling. That's why we're only mounting the radiator symbolically.
Let's summarize the cooling system and go over the components, what goes where and what connects to what. We didn't stray far from the factory setup, we just made a few adjustments based on our layout. From the motor, the pipeline goes directly to the radiator. From the radiator, it goes to the expansion tank. From the expansion tank, it goes to the PDM, passes through the PDM, then goes to the inverter, passes through the inverter, then goes through the electric pump, and returns back to the motor. So it forms a closed system, which should basically work. There won't be any high temperatures here. It will handle it, that's for sure. Our goal right now is to test the car in general, just to see how it drives, where it goes, and what might be wrong with it. Again, we still have some confusion with the automatic transmission. It's still unclear. Will it work? Will it not work? It spins the wheels when they're off the ground, but how it will behave while driving is still unknown. Even within our own team, we can't agree among ourselves whether it will actually drive. Supposedly it might go somewhere in first gear, but will it shift gears, work properly? Will it work when you let off the gas? How will the electric motor behave with the automatic transmission? How do you control all this, especially with the gamepad? We still don't know. The brakes are fully connected only to the front axle. We're not touching the rear axle for now. Even if we get it moving, the front brakes will be more than enough. All that's left is to bleed them. And the steering, everything is ready with the steering. Right now, our goal is to fill the brake fluid and bleed the front brakes. For that, we're using this makeshift lever for now. I'll show you how it works now. Pour in the water. For now, we'll probably fill the cooling system with distilled water, because there's no point in using antifreeze yet we don't know how sealed it is. How is all of this? We're gonna check everything now, and we'll pour oil into the automatic transmission to bleed the system, while Lesha is setting up the connection between the control unit and the... It's leaking. That means the brake fluid has already reached here and will get there soon. It got there. Wait, please don't drip. That's it, we've almost bled the brakes. Look how everything's flowing. Let's get back to our lever. The lever is for bleeding the brakes, while Lesha sets up the control unit for the master brake cylinder. It works, assembled from whatever materials were at hand. It works very simply, just like a lever. So that's what we use to bleed the brakes. Look, the air is already starting to come out everywhere. Let's ask Alexander to help.
As a result, after 15 minutes of these simple movements, the brakes are bled and we can move on. The next step is the cooling system.
For now, we're pouring in regular distilled water to check everything. And of course, in winter, our car won't be driving on the street either. I hope.
Now all that's left is to fill the gearbox with oil, and in theory we can drive. Since we didn't have a dipstick, we couldn't really check the oil level, so just in case we added another liter. After that, we put in the battery to power up the electronics. And finally, the first real startup.
Alright, we can definitely call it now, huh? Oh my! That's it. Public, move away. The oil's been pumped. I think it's because there's not enough oil in the torque converter. So, can someone hold the brakes?
Let me explain a bit. At the moment, this big lever is acting as the brake pedal. That's exactly why we don't stray far from it.
Here it is. See? Yeah, just a little bit indeed. Is there only one dipstick? Well, that's the clutch is burning. We probably need to add more oil. Again.
So the engine is running, but nothing is happening. We revved the engine well, a little smoke came out of the dipstick, and we decided that we needed to add oil plus an extra liter.
I like the way it turns on. We still need to install a toggle switch like that. And so that it sparkles like in those movies.
After which we then turn the engine again, and again absolutely nothing happens. Well, almost nothing.
What? You? Sanya? I'm like, that's it. The car is definitely moving.
We were told that we needed a push, maybe something.
After which the following happened.
Or alternatively, we have this particular individual, we spoke with him and he explicitly states that she possesses valves there. No, he said that if you just keep turning it in dumb mode, in first or third gear, in emergency mode, it'll still go somewhere anyway. What? No one pushed it?
Number?
Basically, in the end, there wasn't enough oil. Maybe it needs to be pumped in every mode? Alright, Sanya, go get some more oil. We'll keep feeding it until it starts working, pouring in another liter of oil and continuing the test.
It actually moves.
At this point, we decided that the problem was clearly a lack of oil. And just to be sure, we pour in another liter. By this point, it became clear that adapting an automatic transmission for our purposes is definitely possible, but it's much easier to just install a manual and simplify the mechanism. All that's left is to buy a new gearbox.
Well, that's it. Oh, wait. We still don't have reverse. If we manage to get first and drive, and we check that,
Reverse is in the gearbox. Try going back now.
that's what I want to do. But there's the battery. Maybe you didn't want to go into the battery. Where's reverse? Drive, park, reverse, right? Who here drives an automatic?
Look, after the drive, the next one is
Second, please wait.
second reverse.
We leave the rear axle off the ground and run the gearbox through all the gears, trying to bleed the entire system. After that, satisfied, we lower the car to the ground, fully intending to drive. But then, once again, things don't go as planned.
Alright, now I'm definitely going forward. Success. If success is over there, then that's where I'm going.
That way,
Then, after another 20 minutes of tests and discussions, the car randomly starts up perfectly smoothly and drives great again. After that, it stops and once again doesn't respond to the gas pedal at all. At this point we came to the conclusion that it would have been better if it hadn't driven at all. So we could just bury this idea and move on to installing a manual transmission.
The radiator is warm. So, is the gearbox heating up? In other words, there is oil in the radiator.
In the end we checked the oil cooler. There is oil in it, and it's warm, which means the system is working and the oil is circulating. For extra reliability, we pour in the last liter of oil, then another last liter and make another attempt.
Well, either our gearbox is dead. Here, it's primed, it has enough oil.
And as you can see, it's another fiasco. And then, through our combined efforts, we finally noticed a pattern. If you shift into gear, that is into drive, at the moment when the engine is at least spinning a little, everything works perfectly. We immediately tested this theory, and that's exactly how it turned out.
There you go, it's moving.
But when we completely stop, it doesn't move forward anymore at all.
Yeah.
The damn steam works somehow.
If I give gas, it moves a bit.
Now it won't go anymore.
Now it's the second time. That's it. The second time it doesn't move.
Well, what do you think if we just push it out while people are around and take it for a drive? It's not a big deal. Go smoothly, slowly, no need to rush. Just drive moderately, turn around, and come back. Since we're already here and it's not dark yet.
And despite hundreds of comments saying that an automatic transmission would never work in such a setup, we proved the opposite. All that's left is to sort out a few details. For a full-fledged test drive, we took the car out to a special closed track, and as you can see, everything steers, handles and drives perfectly. The only issue was the phase brakes. One of the connections turned out to be defective, so we were driving at minimal speed. But there was a huge power reserve. In fact, we were only pressing the button by 2 or 3%. Let's sum things up. Initially, we installed an automatic transmission, and yes, that was a questionable decision. We only did it because we had that transmission on hand, and we figured the setup should work. We were specifically interested in testing this combination, keeping in mind that we would replace this transmission with a manual one at the first opportunity. Of course, we made sure in advance that there were interchangeable manual alternatives available. That's exactly why we immediately made a solid mount and all the adapters. In addition to hundreds of comments saying that an automatic transmission would never work, there were also several hundred comments claiming that we didn't need a gearbox at all in this setup. That's partially true. The car really would move without a gearbox, but not for long. We'll get to that a bit later. For now, we're rolling the van back into the garage and moving on.
We ran some tests, everyone saw them, and still decided to try installing a manual transmission here. It drives though, with some quirks, not without them, but it does drive. The interesting catch is that it only truly moves if, after carefully putting it in park, we then vigorously rev up the engine, and just before it comes to a complete and utter stop, we quickly switch it to drive then. It finally goes, it readily responds to the gas pedal, smoothly accelerates, and you can easily let off the gas and then firmly press it again. Everything's absolutely great. Like, we're basically satisfied with everything. But then there are these little quirks. Plus, it started leaking like crazy. From everywhere. From the seals located right here, the gear selectors, and even down by the oil pan itself. There's no point in repairing it. So we're gonna try putting in a manual transmission. Now we'll pick a manual transmission that fits our flange and will require minimal modifications.
Before installing the brand new gearbox, first we carefully remove the old one, and then we can finally move on.
We got a gearbox from guys at the scrapyard. On condition I can return it if needed. Well, it looks similar, but we need to measure. The gearbox I brought last time didn't fit at all. It didn't fit the bell housing, and in terms of length, it didn't match up in any way. Someone told us that any gearbox you buy will fit. Visually, they all look very similar, but each one still has its own differences. This time you took a different gearbox, and as it turns out, it doesn't really fit us either, but at least there's a chance we can install it on the car because some of the holes will line up. Well, we'll just drill the rest. But the main thing is that it fits at least some of the holes so that the alignment is maintained. We also need to buy a clutch disc for it so we can use its splined part. Now I'm going to try installing it on the car. This is what it looks like with the manual transmission marked up, only the two top bolts lined up. Visually the input shaft looks good. It also fits perfectly with the engine. As for what we'll have to modify, we need to replace the rear universal joint, this coupling on it, so that it fits our flange, and also adjust the mounting of the support bracket, moving it a bit to the left. Other than that, it genuinely looks like we might not even have to extend the drive shaft at all, because it actually moves quite a bit here on the splines, which is really convenient. We might have enough distance, so overall things aren't that bad. Another important thing which I also paid attention to when choosing is that the gear shifting mechanism should preferably be linear. So here the gear shifts only in a linear fashion, meaning two directions. This is the gear range selector, and this is the actual gear engagement. So two functions, push and pull. There are no brakes or anything like that. This means we'll be able to set up remote control for disengaging the gears if we need to, at least for simple forward and backward movement. Okay. Well, since we've decided to go with this gearbox, the first thing we need to do is clean it. That's the most important thing, because right now it looks absolutely terrible. We'll replace the rear tail shaft and remove all these unnecessary parts. We'll get it into a condition where we can actually work with it, and then we'll get started. We're waiting for the clutch disc from which we'll use the central front part. Here's what the clean gearbox looks like, much neater, and now you can touch it without risking your health.
Now the rest is easy. All that's left is to come up with a couple of adapters and inserts and then put the gearbox in its rightful place. But first we'll remove everything we need from the old gearbox.
The urgent anticipated package has arrived. It took 3 days to get here. We waited for it forever. It's all finally here. I used clutch basket and this, so we can now install the manual transmission. All of this old and worn out material is going directly into the trash. We had to overpay, of course, but all we really need is this front part. Our goal is to take this front part out so we can feed it together with what we have on the gearbox. That's what we're gonna do now. The lathe cutters arrived right away, so perhaps we will be able to make the very first shavings today. I just unpacked them. The goal is to check if it even fits our gearbox. Perfect. Exactly what we needed. No wonder we waited 3 days for it. So what do I need to take apart? Most likely I'll need to drill out all these rivets to carefully remove the center and then connect this center to our old adapter. Where is our Nissan Leaf faceplate?
After that, all that's left is to align all the mounting points, freeze apart and get the hang of the lathe. That's exactly what Kolya started doing. Jumping ahead a bit, I'll say that the whole process took just under a day. By this point, we were pretty tired of going to the machinist every day, so we finally decided to buy a simple lathe to at least handle basic needs ourselves. By the way, if you are planning to buy a machine from Jet, now is the perfect time. Until the end of November, they're running a Black Friday promotion with great discounts. By the way, that's where we snagged our lathe.
I disassembled the clutch and the disc is exactly what we needed. I measured everything on the mechanical side, specifically the front part. It turns out that we need a distance of 20 millimeters here. Now we're gonna cut off this excess part completely so it doesn't get in the way. Here we've machined it, centered it on the lathe. When we were machining this spacer, I asked the guys to make sure all the surfaces were aligned in a single pass. And this tube here has thick walls. I think it's 35 millimeters or so. I can't really remember now. It's seamless. We machine an adapter from here to here, press everything together and weld it. So that's the plan for now. Now I'm gonna try to make it all happen. No one has really worked on the lathe before, so we'll be learning as we go along.
Yes, it's true, no one on our team really has experience working with a lathe. That's exactly why we got a small benchtop lathe, which we are actually very happy with. I hope that over time we'll move up to a large professional lathe, but for now we'll outsource the more complex tasks and handle the simpler ones ourselves, gaining experience and developing our skills along the way.
I've made the first part, turned it on the lathe. Here it is, and it's going to be inserted here. It fits very tightly, so nothing will move at all. Now, the main idea is to carefully prepare this part, precisely cut off the excess to make it perfectly round, and then securely weld this to the flange. And then clamp the whole assembly and machine the required diameter here for this so that everything is as aligned as possible. I haven't decided how to do this one yet. For now, I'll probably cut off the excess with an angle grinder and then just clean it up on the lathe. That's probably how I'll do it. Here's the first chip, guys. Beautiful.
After a few more passes, the assembly is basically ready. All that's left is to put everything together.
Here it is, prepared. I taped off the part we'll be using as a reference later. Once again, I truly can't help but admire this remarkable table. We use it practically everywhere. I even mount GoPros on all these various fixtures, and I always carefully set it up so that there are no clamps or anything underneath, so that when welding, the ground doesn't cause the bottom to stick. That's it. I can easily rotate it like this and weld right here. Maybe I can even do it in a single pass. So, in my immense excitement and considerable rush from how incredibly well things are truly going, I've already carefully fitted this particular part in here. It went in with a very light tap from a small hammer. Really, I just gently tapped it a little bit. There's a chamfer here, and there's a small gap left on purpose so I can weld it all up now. Everything spins. There is some run out here on the flange, but the flange isn't involved this time. You could even cut it off, but I just didn't because it doesn't matter at all. All the splines are here on this side and on that side. Our adapter is ready. Let's install it. All right, now I'm gonna try to fit the gearbox in. The gearbox is in place, the two upper bolts have lined up, and that's already a good sign. It's centered, all the shafts are connected, everything spins. You can hear that when I engage the gear, the electric motor spins. Nothing's wrong anywhere. Well, everything seems to be fine. Now the task is to add mounting holes. Here, I'll add 2 and probably 2 more at the bottom for now, just to check how this whole setup behaves and works for the first test run. About the drive shaft, I changed the rear flange, installed the coupling, and removed the dust cover from here so I could see how many splines we have, the length of the splines. If you just install it like this, first of all, the bolts won't screw in here, and secondly, there aren't enough splines. So for now, I'm temporarily putting in spacers here for mounting. I'll probably make the spacers out of this flange. I'll just cut it like this. It's even here, and there's a hitting, so everything should be precise. We're not going to be speeding up to crazy speeds on the first test run. And in the future, to avoid redoing the drive shaft, which is expensive, we'll most likely add another spacer here and also add a spacer on the yoke, which will push the splines further inside. I'll put the dust cover back on, and everything will be assembled. There's still an unresolved issue with the rear transmission mount. This one doesn't fit, the transmission is shorter. The mount in theory fits the transmission. The support just needs to be moved out a bit. So now I'm going to cut this off, move it out, and weld a new bracket.
As you can see, all these tasks were set by Kolya himself, and without hesitation he immediately set about accomplishing them. In the end, we drilled the missing holes and top threads in them. Then we cut off the mounting plate for the support and firmly secured the transmission in its place.
I cut off the old mount, I separated the plate from it so I wouldn't have to make a new one, and the tube as well, I cut all of that apart. And I think I'll even put this particular tube back on this side and then run a second one to the completely opposite side for additional support so that the mount doesn't wobble at all.
As you can see, Kolya put together an excellent team, and after getting a clear action plan, he immediately set about carrying it out. And by the end of Kolya's day, we have this beauty right here.
On the technical side of things, everything is now completely ready mechanically. I have successfully connected the drive shaft. Here are these small, precisely crafted spacers, which are pieces carefully salvaged from the previous flange. They fit into the groove here and they have a flat surface, so there really shouldn't be any problems. Whether it's temporary or not, I don't know yet how it will hold up. I welded this piece together. I haven't fully welded it all around yet, just welded it on this side. Later, when we take everything off to paint, I'll weld it from the other side, the reverse side. We're in a rush now because we need to get out soon, since it's gonna start raining. It's already kind of raining, so it's really urgent for us to get out. So we're hooking everything up now. It's probably already damp outside. We'll cover everything here with stretch film to at least protect it, and we'll try to do a test drive because winter is coming, and until everything is finished, closed up and sealed, we won't have another chance. The madness only grew stronger, so the world will see this kind of creation for the passenger seats to control this wonder. Since we haven't finished setting up all the controls from the gamepad yet, there are still some things to work out. This is what the drivers and passenger seats look like. As it is, sticks, boards, zip ties, all classic stuff.
In the end, we decided not to wait for good weather, which might never come, so we packed up the car and took it out for another test drive.
I still really don't like the brakes. It seems like they're missing the electrical component, and that's it. So, are we gonna try it? Look, the brakes, look, the brakes, look, the brakes.
As you can see, everything works perfectly. All that's left is to sort out the brakes and connect everything to the gamepad. Definitely a manual transmission is the right choice, and here are a few words about why it's even needed. Basically, we're using the gearbox for its intended purpose to change the gear ratio. If you connect the electric motor directly to the rear axle, you'll put a heavy load on the motor. Yes, of course, electric cars don't have a gearbox, but everything there is set up completely differently. But in order to get our wheels spinning properly, a gearbox is still necessary. In the next episode, we'll do a simple calculation and demonstrate it clearly. Thank you for watching and wishing you all the best from Topor.